So yes, good morning, good afternoon. First of all, I really would like to thank all of you for attending this Angus webinar series. I am Romain Savrac, Global Technical Leader for painted coating at Angus Chemical Company since early 2016. I am based in Paris, where we have implemented one of our 6 applicative labs dedicated to not only but also for pattern coating related topics. Today, I'm very glad to be here with you and share our latest contribution to the improvement of the indoor air quality. This webinar for us is really a great opportunity to understand and to share the impact of our additives in a water-based paint, not only for lowering paint emission, but also as a pollution remediation by scavenging formaldehyde. Before to start with the presentation, I just would like to share with you that after my presentation, I'm just going to open a Q&A, a question and answer session. So meaning that during the presentation or during the Q&A session, you are going to be allowed to share question with us. You just have to use the Q&A tool of the WebEx software. You might find a window on the right side of the WebEx window where you can write, basically, you can write your question, and then our moderator will share the question with me. Good. As an introduction, I would like to start with this pollution survey, which is probably one of the key drivers leading to the special focus in indoor pollution. This is an analysis of airborne VOC concentration in residences, daycare centers, and schools in France in 2010. The conclusion of this investigation, as you can see here on the different histogram, is by looking at the top 4 molecule of VOC or pollutants we can find in indoor air condition, 3 are aldehydes, and the first one is indeed formaldehyde. As a result, both local manufacturer in France, indeed, but also French regulators implemented some actions in order to address this concern. And it is mainly a 2-step solution. If we look at the evolution of let's say paint development in relation with this indoor air quality, the first solution is indeed to work on reducing, improving, minimizing the emission of the film by itself by minimizing the VOC content of water-based formulation. And as a second step, we can also imagine to add a particular functionality to the coating, enabling the dry film to not only be inert but actively remediate the pollution from a room. And during this session, we are going to cover both angles and discover how Angus solution can, let's say, contribute in each case. So before to go directly to the result and our conclusion, I just would like to start with a quick Angus presentation, and also to cover and to look at our amino alcohols, our let's say amino alcohol product portfolio, just to be sure that we are starting with the same at the same point. Obviously, I'm not going to let's say go through a detailed company presentation. This is really not the scope and the purpose of this talk, but I think it is important to keep in mind and to understand that Angus is really able to offer a unique range of products, and it is mainly because of this first chemical step of our supply chain. We are really expert in the nitration of propane or natural gas, if you wish, leading to the formation of nitroalkanes. And from nitroalkanes compound, after a couple of chemical reaction, we are able to develop Probably the most famous part of our range of products, especially in paint and coating, our amino alcohol products. With and the amino alcohol, this is exactly what we are going now to look at in more details, because they are the multifunctional, well-known product of the ANGUS portfolio, able to develop, let's say, low emission paint, and also developing this reaction with the indoor formaldehyde. So as a reminder, because I'm pretty sure that most of you on the phone are pretty familiar with the different molecule, but just in case, they are just here. This is really a selection of the 4 major amino alcohol that we are proposing and we are offering for the paint and coating application area, starting with AMP. Meaning a 2-amino 2-methyl propanol, then AEPD VOCs 1000, which is the 2-amino 2-ethyl 1,3 propandiol, then the dimethyl version of AMP, namely the DMAMP, and the last but not least, as we will see later, but the tris-amino crystal corresponding to the molecule with the chemical name tris-hydroxymethyl aminomethane. What is I can spend 1 hour only on this slide, but just 2 important points here. If we look at the chemical structure of the 4 products, what is really important to stress and to notice, first of all, if we just have to quick look to the chemical structure, all molecules are extremely small molecule, meaning that they can really diffuse and let's say move quite fast in any water-based formulation. Also, we can see that we have 1 or more primary alcohol and at least 1 amine, obviously. It's obvious, but it means that with this high level of functional groups, this type of molecule, they are really the ability to react or interact with other ingredients of the formulation. And this is really the main reason of most of the property of our product. It is really because those products can interact with other ingredients that we can boost, we can develop synergistic effect with other ingredients, leading to property improvement. Last point is really about this carbon here in the center of the molecule, stick to 2 methyl groups, providing a high thermal and UV resistance. And as you know, it is important because it's explaining why all those products are not affecting the yellowing or the color drift of the dry film. And thanks to all the interaction, also we can say that this product could affect the entire life cycle of pens, from the manufacturing of the coating to the let's say the dry film via the application of the paint, and of course the in-can stability, which is as you know, very important benefit of our products. The multifunctionality is based on several chemical equilibria, such as an example, again, I'm not going to explain in details all this slide, but just one example. The first reaction, explaining why our products are so good as a weighting agent. It is simply because they are absorbed at the pigment surfaces, such as titanium dioxide, for instance. But here today, to this, let's say, a multifunctional toolbox, we can add this, the 5th reaction. So this ability for our product some of our product, I should say, to react with formaldehyde. In this slide also, we can see that we are giving also some recommendation regarding where the product should be loaded. So for pollution remediation, so this is what it is about when we are talking about formaldehyde scavenging property. You can see that it's quite flexible. You can add the product either during the dispersion or during the letdown, or both. In terms of concentration, it is one of the benefits requiring a relatively high concentration compared to other effects, but it is still in a, let's say, in a relatively low range with a trisamino, with AEPD. As we are going to see, our recommended, let's say, range of concentration is between 0.5% by weight, by, let's say, total weight of the plant of the recipe, up to 0.8%. Last question is which product, which chemistry is going to fit your need. So this is what this spider graph would like to answer. So if we just look at the remediation, so pollution remediation dimension, I'm not going again to cover and to explain all the dimension of the product, but just looking at this one, we can see that trisamino is clearly our champion regarding this ability of reacting and scavenging formaldehyde. We've also, what is important to highlight, a very friendly EHS profile, because if you look at the safety data sheets of trisamino is not classified and also is not labeled. So it is a very friendly molecule, like all other products, I would say. But trisamino with really no classification, it is really untypical. And next, or after trisamino, the next best product is AEPD VOCs 1000. We will see it's not as good as trisamino. It can offer a certain level of scavenging property. The difference is if you look at the surface covered by the product on this spider graph, we can really see that trisamino is mainly a scavenger. AEPD is not as good, but can offer a wider spectrum, I would say, of multifunctional benefits. So this is more or less the conclusion of the presentation today, but the rest, and now what I'm going to do, I'm going to share all the results, allowing me actually to develop the conclusion I'm sharing here. And let's start with a little bit of background about the origin of this formaldehyde remediation issue. Very quick, first of all, just to confirm the concern pointing formaldehyde. This is just a copy paste of the ECA website, highlighting the classification of formaldehyde. You see it's speaking by itself. It's very so the product is toxic and also carcinogenic, at least. So that's why it is really a molecule of great concern for indoor air quality. There is also one of the issues is there is multiple sources of formaldehyde in our house, in our homes. It can come from basically from furniture made from particle board, as an example. They can contain some unreacted formaldehyde, because formaldehyde is a raw material for this type of product. Also, this the resin used in particle board can let's say release formaldehyde, because the cross-linking reaction can be reversible as a function of temperature and humidity. We can also have some kind of, if I can say, natural source of formaldehyde, if in case of combustion, so can come from cigarette smoke, but also from fumes. Also, if you are, for instance, if you have some fruits and if you have some compost in your kitchen, for instance, you can also generate formaldehyde in this area. And formaldehyde can also come from outside of your house, from the outside air, and also from a reaction between the let's say atmospheric ozone and some molecule, again leading to a formaldehyde presence. So multiple source, so it is not easy to cut and to minimize all the source of formaldehyde. And this graph is I think a very good summary of just to have an idea of, let's say, the link of the safety or let's say the safety zone containing formaldehyde as a function of formaldehyde concentration. And as you can see, the World Health Organization sets as 80 microgram per cubic meter the threshold where the presence of formaldehyde is considered as critical. So, and just for information, in most of our European country, in average, I would say the concentration of formaldehyde is typically observed at about 20 to 30 microgram per cubic meter. So we are not so far from the limit set up by the WHO. It is important also to stress and to list the methodology, how to measure the efficiency of a product. So for that, there is different method which are implemented in different regions. Primary in Europe with the ISO standard, and in China with a JGT standard. So for emission, we are mainly relying from I'm going to be very focused on ISO and let's say European standard today. So in Europe for emission test, we are mainly focused on the ISO 16000-6 protocol, and for the scavenging property, it is about and it is mainly the ISO 16000-23 standard. I just would like to mention that we also first of all, I'm going to share our data for both ISO standard, but for your information, we also develop a data package with both Chinese standards. So if you would like to get access to our latest result with the Chinese protocol, feel free to come back to me. All right, so let's start with the demonstration about the low emission according to the ISO 16000-6 standard. Starting with a quick description of the methodology of this European standard. This is a picture of the setup. So you see that the test is performed in a climate chamber where we can control temperature and humidity, so respectively 23 degrees C, 50% relative humidity. The climate chamber is a 119 liter of volume. There is an exchange rate, so let's say there is a it's a dynamic test, huh? So we are the protocol is based on the fact that we are continuously loading and flowing, I would say, a flux of air corresponding to 50% of the volume of the climate chamber per hour. We can install here on this specific system the sample, so the panel containing the dry film. And so then we have two protocols, the -6 and then the -23. So with the -6, what we are doing, we are just, again, we are setting up the dry film in the middle. We are injecting a synthetic hair, but if I can say a pure synthetic hair. And we are measuring during 28 days, up to 28 days, what is expelled from the dry film. And the measurement is performed with a GCMS analytical system. So that's why you can see a lot of tubes and a quite complex setup on the picture at the bottom, because you have to inject continuously air, and also at the same time you have to recover what is expelled, what is from the room, and it is directly sent to the GCMS system. So this is for the -6. The difference with -23, where we would like to measure the efficiency of the dry film as a formaldehyde scavenger, is that obviously instead of injecting a pure hair, a pure synthetic hair, if I can say, we are going to inject contaminated hair with a known concentration of formaldehyde. And typically, typically the injected concentration of formaldehyde is 100 microgram per cubic meter. So just to remind, so typical concentration of formaldehyde in our indoor environment, it is about 20, 30 microgram per cubic meter. WHO is setting that 80 microgram per cubic meter. It is, I would say, the safe limit, and the test is performed at 100. So it is more or less roughly four times the regular or the average pollution of European cities. What I'm missing here, I think it's okay. Yeah. So let's start with so we are going to cover both standard, but we are going to start with the low emission -6, and then I will continue with the -23. So for the -6, we have prepared some model water-based formulation. So here, this is a composition of the a water-based satin formulation, of course, interior satin deco pants with a PVC of 40%. For this one, as the next one, we are always slightly below the CPVC, and just to be a little bit more challenging, we do not want to have a porous system. We want to have a dense film system in order to avoid the porosity of the film. And we just performed two formulations, one containing 0.3% of AEPD and one containing 0.3% of AMP. If we just look at the, for your reference, the boiling point of both products, so the boiling point of AMP is about 160 degrees C, so it is considered as a VOC according to the, let's say, boiling point definition in Europe. AEPD, it's not, because the boiling point is higher than 280 degrees C. And then if we look at the emission tests, so you have a summary, but it's an easy summary of the what is expelled from the climate chamber. What we can see is that the AEPD based formulation, it is clear, because we can clearly establish that an AEPD containing formulation is not going to contribute to the VOC and the total VOC detected. So yeah, AEPD is clearly a very good candidate for measuring, for developing low emission pans. And even what is interesting to notice is even AEPD in AMP, sorry, AMP is only slightly contributing to as a VOC, not because AMP is not a VOC, because as I said, the boiling point of VOC is much lower, but it is likely that it is based on the very high affinity between AMP and pigment surfaces, leading to the fact that despite the lower boiling point, AMP is going to widely remain, I would say, in the dry film. All right, so let's go to the last topic. So the second step, contributing to an improvement of the indoor air quality, based on the reaction with formaldehyde in coating. So again, this is one of the new tool we can add to the multifunctionality definition of our product. And so with the ISO 16000-3 standard. So what are the testing conditions? Quite common. We just followed the classic setup of the norm. So 50% exchange rate, you can recognize a 50% relative humidity, 23 degrees C. The area, so in our hypothesis, we set up the test for walls plus ceiling coated. So this is leading to this loading factor. We prepare the specimen, so the sample with two consecutive layers of 140 grams per square meter, setting up a drying time of 8 hours between two applications. very standard protocol conditions. And as I mentioned before, we set up the test with 100 microgram per cubic meter of formaldehyde all along the test. The formulation, very simple, but the scope, the goal here was really to develop a simple and a kind of model decopants system with an acrylic binder. It is also a satin in interior decopant, and we prepare the pant by loading our multifunctional scavenger during both let's say during the dispersion and also completing the dosage during the letdown. We also, I can come back to this point during the question if needed. But so this is the recipe. And first of all here, so we are going to compare our two leading products. So first trisamino and then AEPD. But let's look at the graph axis. So here you have the percentage of consumed formaldehyde at a specific time. So it corresponds basically to the scavenging power of the dry film. If the percentage is high, it means that the dry film is able to scavenge, to trap a high percentage of the injected formaldehyde. And it is as a function of the day of exposure, day of exposition. The ISO test is saying that you can do the test up to 28 days. In our case, even we did not stop the test after 4 weeks, but we continue after 6 weeks of test just to be sure of and to ensure that the efficiency is long enough. Clearly, we can see that trisamino, so here in green, at only 0.5% in total of the weight of the formulation, so extremely low concentration. Even at 0.5%, we have, of course, a drop, but this is always the case. We can also see a drop of percentage of consumed formaldehyde, but even after 6 weeks, still we can continue to scavenge at least 50% of the injected formaldehyde, which is a extremely good result. With AEPD at the same concentration, we can see that we can also show and see a drop, but the steady state, I would say, of the equilibrium and of the scavenging property is much lower, reaching about only 20% of efficiency. So we can clearly see the difference between trisamino and AEPD at the same dosage. Then it was also important and interesting to check the optimum concentration or dosage of trisamino. So in order to do this, we prepare 3 pants with 3 different trisamino crystal concentration, respectively 0.35, 0.5, and 0.8% of this additive. What we can see is, yes, as we are increasing the concentration of trisamino, we can increase the scavenging property, but there is not a huge difference between 0.5 and 0.8. Let's say the chemical equilibrium between the trisamino entangled in the film and the formaldehyde in the atmosphere is the same, 50%. So our recommendation at this stage of our understanding is to say that 0.5% is enough, and 0.5% it's a very good compromise between the efficiency and the overall performance of the product. Why also we can see such high efficiency with trisamino? There is probably different reasons. One of the reasons is the stoichiometry of the scavenging. You can see. So this is, as a reminder, this is the chemical structure of trisamino, the 3 primary alcohols and the primary amine, leading that you see this molecule can react with 1, but not only with 2 moles of formaldehyde. So 1 mole of additive can scavenge actually 2 moles of formaldehyde. So it is a very, very good and high weight efficiency for the product. That's why, let's say, with only 0.5% of this additive, we can reach such a high performance. Also, yes, it is as always, and the reaction here are reversible. And what is interesting also, what is probably specific with our solution is the product of the reaction. So in this case, if we talk about trisamino, the product of the reaction, so this molecule, which is an oxazolidine, it's called it's a zoldine ZT. In our portfolio, this molecule is a commercial product, and as it is a commercial product, we can also, if you want, we can also provide you with the safety data sheet of the product of the reaction, enabling you to really to do a full risk assessment of the system, right? And this scavenging reaction is patented, and so we have protected, I would say, this solution with the patents. Yes, also, and I think it's the last point of our discussion today. It is always, we always have a tricky question when talking about that with you, with formulators. It is to try to translate, if I can say, the ISO standard to I would say to real life, because ISO standard it's only 28 days, or in our case slightly longer, but you know, the idea is not only to protect a room during 28 days. We all want to have a long-lasting protection, and so by doing a theoretical and a simulation, just really simple exercise, but just using an Excel spreadsheet. Here I am trying to translate the ISO 16000-23 protocol to what could it mean let's say in reality. So the condition and the hypothesis of this calculation is to say that we are going to load virtually. We are going to prepare a formulation with 0.5% of, in our case here, trisamino. We are going to apply this coating at 12 square meter, per liter of coating. We are going to apply 2 layers, and we are going to apply that in a kind of virtual room, about 30 cubic meter, corresponding to about 14 square meter of coating surface. So it means that we are coating all the walls, the 4 walls of the cube, if you want, and the ceiling. The formaldehyde concentration that we are going to inject in this room is at about 30 microgram per cubic meter. Because it corresponds to, in average, what we can measure in European cities. The exhaust system efficiency, so the air renewal inside of this virtual room, is at about 50% per hour. And so the efficiency is based, obviously, on the ISO standard test. Yeah, just to say that the 30 microgram per cubic meter it is one example here coming from an analysis of the Paris indoor air quality. So we can see that in average we can find, so that's why it's 27.7. So moyenne, it means average in English, in French, sorry. So that's why in the calculation I set up the calculation at 30. And this is a sample spreadsheet, so 0.5% of trisamino, pen density. No, in this case it's 8, sorry, it was not 12, it's 8 cubic meter per liter of coating, 2 layers, and the air renewal. And you can see that at the end, if I'm considering the 50% efficiency, what we highlighted and discovered during the ISO test protocol, we can have a 50% efficiency, so a 50% formaldehyde reduction during something like 13 or 14 years. Again, I'm not saying that it's not about giving a guarantee or let's say, but it is just to give a range. It is just to give us an idea of how long this product, this chemistry can act as a scavenger when loaded only at 0.5% in a water-based system. Conclusion of this presentation. So in the current, I would say, challenging environment of plant development, targeting first a drastic reduction of VOC emission, but also preparing the next step, consisting of using, let's say, additive or more, let's say, broader than that, to use a coated surface as a key player for the improvement of the indoor air quality. So we can offer both solutions. So for lowering the emission, we can offer AEPD VOCs 1000, which help to develop let's say low emission pants according to the ISO standard. And not only because as AEPD is a multifunctional additive, it's not only a matter of no developing negative impact on the other feature of the pant, but we can also improve the pant properties such as in-can stability or the titanium dioxide dispersions leading to a better hiding power, or we can also demonstrate that AEPD can boost the microbial stability when combined with registered biocide. And for the second step, trace amino crystal enable to add the formaldehyde scavenging power to a recipe, even at low concentration. Again, 0.5% seems to be enough in our case. And we can also demonstrate, so for the overall plant performance, we can also demonstrate that trace amino is not going to positively impact overall property of the plant, but it's not going to negatively impact or disturb, I would say, the formulation. So depending of what you want to achieve, depending of your need, you can pick up AEPD for low emission or trace amino crystal for formaldehyde remediation. And with that, I will just thank you for your attention. And now we can open the Q&A session.
Good morning, Roman. We've got several questions that have come in. Can you hear me okay?
Yes, I can. Good morning, Scott.
Okay, great. Good morning. And thanks to everyone for your questions. If you have others, please add them into the Q&A chat function on the WebEx webinar screen. First question, you mentioned just now that trace amino does not have any negative impact on the overall paint performance. Have you done any analysis in this area on in-can or dry film, and can you elaborate on the results?
Yeah, sure. It's obviously a good question. I was prepared for that one. So yes, indeed. What we performed in order to ensure that we have at least no impact, no negative impact, and eventually to demonstrate that we can have also positive impact, is we also prepare with the same recipes as, remember the formulation I shared before. So we submitted the same formulation to Eurofin. So Eurofin, it's our, I would say, the third laboratory we selected for the scavenging test. And so in our lab, we perform a series of tests consisting of checking the evolution of the pH, so with a weekly measurement during 8 weeks. Also the viscosity, classic, there is nothing strange here. So we also checked as a function of time the evolution of the ICI viscosity and also Brookfield viscosity at two speeds. The in-can stability, so just a visual assessment. Again, a weekly check when the product is set up in an oven at 23 degrees C. Also, which is extremely important because it's a classic question and a very good question because when you are loading, when you are adding a scavenger, especially if you look at the chemical structure of trisamino. You have the free alcohol group plus the amine function. So it seems to be a very hydrophilic molecule, right? So it makes sense to be concerned about the potential negative effect of trisamino on the wet scrub resistance, because also in this case we are sure and we want the product be in the dry thing at the end. Yeah, we do not want to have any evaporation or removal of the product during the drying. We check classic gloss, or let's say spectrocolorimetric test, including hiding power and the evolution, and last but not least the hardness. We tested a series of products. I'm not going to go in too much detail, but we tested different trisamino, including AEPD, and we also tested the product of the reaction. So Zoldyne ZE, as a reminder, it's the oxazolidine coming from the reaction between AEPD and 2 moles of trisamino of formaldehyde, sorry, and Zoldyne ZT is the product of the reaction between trisamino and formaldehyde, because one can argue, but as soon as your molecule scavenge formaldehyde, is it going to affect negatively or maybe positively the dry film? So with all of this, so quickly review the data. Again, I can come back to that in more details if there is more question. But first of all, regarding the scrub resistance, which is one of the key, I would say, question. If I'm referring to the discussion I could have with formulators, we can say that yeah, it's a classic test, and based on the ISO 11998 standard, we can say that. So this is the percentage of removed coating as a function of the percentage of added additive, right? So from 0.35, 0.5, and 0.8%, with 2 grades of trisamino, with AEPD, and also with Zoldyne. And we can see that compared to the control, so the control has been prepared with caustic, we have no significant difference between all systems. So we can say that no, there is no impact, no significant impact of the presence of neither AEPD or trisamino or the product of the reaction, so the different oxazolidones with the web scrub resistance. Regarding viscosity, it is the same conclusion. If we look at the statistic analysis, you already have the control, trisamino, deoxazolidine, AEPD, and the corresponding oxazolidine again. Honestly, there is no, statistically speaking, there is no significant difference in terms of viscosity or evolution of the viscosity. It is the same with the gloss, with the free classic angle. Maybe a slight impact of AEPD on the gloss, but not a big difference, I should say. Where it is in spectrocolorimetric, so delta L star, delta A star, delta B star, again, no difference, exactly the same. What is interesting maybe is to highlight the hiding power. We can see, so this is the control with caustic, and with AEPD, we can clearly see an improvement. The hiding power is clearly higher, not 1 unit, but 0.8 or close to 1 unit of difference. Trisamino, probably we can see also a difference. It's not as efficient, as good as AEPD. Again, we know that, and we know that AEPD is really more multifunctional compared to trisamino. But at least with trisamino, we do not see a negative effect. If I can go back to the conclusion, where is it? Yes, here. So no negative impact of tris on the overall pen performance, and few benefits, especially in the hiding power with AEPD. I hope that it covers this question.
Yep, and we've got several questions, so let's try to move through as many as we can. Have you analyzed any color shift or yellowing in paint after the addition of trisamino on a long-term basis?
Long term, this is what I was sharing. If we look at the delta L, delta E, no impact. We are checking the plant by itself, and we are on ongoing work today at the lab where we just apply the dry film, and we are exposing the dry film to how to say that to the lab condition, just to see if we do see an evolution of the color. The test started at the end of July or beginning of August. In this time frame, as we speak, we do not see a significant difference between the control and the different formulation containing trace. So no impact on positively or negatively on yellowing.
Okay, great. Beyond indoor paint formulations, have we looked at or evaluated the use of trisamino in other building and construction applications such as concrete, mortar, or gypsum?
Alors yes, and in fact for the history and back to the patents I mentioned before from Angus, this patent has been granted in 2010. And it is around the famous and the unfortunate situation that face your side of the ocean, Scott. So the Katrina hurricane, which affected the south coast of US, and when very quickly the US government have to set up how do you call that, Scott? The mobile home for people waiting the reconstruction of cities. And when the health ministry, the Ministry of Health of US made some quality check of the air quality inside this type of mobile system, they discover a not acceptable level of formaldehyde. So quickly they try to find a solution in order to drop the formaldehyde concentration inside of that. And this is where, for the first time, we discovered the effect of trisamino. But also we have some not from Angus, but at least I can share this example from Saint-Gobain, who patented they patented the use of trisamino again in a mortar solution. So yes, it can work also as an example in a mortar system. I have no data, but I know that it's also working in plasters, according to some literature. And also we have nothing to do with coating, but we have some example where trisamino is also used for a house or for a specific building. Trisamino can be used as a coating for the filter of air exhaust system. So you can let's say develop specific filters coated with trisamino. Usually it's a combination of trisamino and activated carbon at the surface of air filter, and this can react and reduce VOC content of via, let's say, the air circulation of the exhaust system. I think we have no more example.
Yep, that's good. And we will, for the folks on the phone, we will send a follow-up to the team with a copy of the presentation, and we'll answer some other questions if we don't get to them. Several questions, Roman, around the reversibility of the reaction between tris and formaldehyde. Is there a release of FA back into the air over time, and under what conditions?
Yeah, of course, it's an important question. It's a reversible reaction. So depending of the condition, yes, it's possible to have the reversibility of the reaction. If I go back to this one. What we know is reversibility is mainly depending of two parameters. So it's temperature and pH. They are the two, if I can say, catalyzer of the reaction. Let's start with the pH. We know that this oxazolidine is extremely stable in a neutral or alkaline condition, which is obviously the normal condition of a coating. If you add an acid compound on that, yes, you are going to release and move, let's say, back and release trisamino and formaldehyde. But in normal condition, the wall is not supposed to, let's say, to be in acid condition. So normally it's not a big issue. And then you have the question of temperature. So what we know is the reversibility, the reaction is reversible only if it's always reversible, huh? But if you want to have a significant reversibility, you have to reach at least a temperature of 70-75 degrees C with trace amino. And so in a room, at least in your house, I hope that you are not reaching very often 70 or 75 degrees C, Scott. So normally, the reversibility is not, let's say, pretty high. But again, it is an exchange. Huh? There is as it is an equilibrium. It is reversible by essence. Like most of the scavenger today. If you look at the different existing solution for that could act as a scavenger, as far as I know, they are all providing a reversible reaction. Huh?
Is that, in a follow-up question, have we done any desorption tests with trisamino-containing paints?
Yes, exactly. At the end of the test, we are always setting a 1 day. It's quite common. Huh? We are always setting a 1 day desorption test. Or no, in fact, it's not exactly that. We for who don't know the setup. So after let's say you are setting up a 28 days or 4 weeks absorption, what you can do, you can add. It is not mandatory, but it is optional. You can stop the injection of the air containing formaldehyde. You can inject then a synthetic air without formaldehyde, and you can measure the quantity of formaldehyde which is released from the coating after. Could be 1 day, could be 3 days, could be. It's up to you. And what we perform that after 1 day, and yes, we can see some formaldehyde back from the film. But again, it's with 28 days of injection of 100 gram per square meter formaldehyde. So it is a quite harsh condition, and we can see a little bit of formaldehyde. At least it is of course not. It is detectable. Yeah, sure.
Okay, a couple questions on, have we tested trisamino performance against other technologies for the same formaldehyde scavenging purpose? And what about odors?
Odors of formaldehyde, of trisamino?
The odor, the ability of trisamino, I'm reading this, to scavenge odors as well, in addition to formaldehyde.
Okay, good question too. So first question, yes, we did. So we did compare our technology to existing solution. I'm not going to share that with here today because yeah, it is not fair if I can say that. We can say that we have a very robust solution compared to the solution we existing on the market, and we compare with. So yeah, we are very, I can say, very proud of the result and the data we are sharing today. Regarding odor scavenging property, it is clearly a topic. We do suspect that we can, but unfortunately, at this stage, in fact, I'm not aware, to put it this way, I'm not aware of any standard method enabling to measure the odor scavenging property of a dry film. So if there is any suggestion for attendees, I'm very glad to see what can be offered, but it is not easy because we cannot measure that. But for instance, we know very well, and it's a well-known reaction, that our amino alcohol, they can react with mercaptans, with thiol. And thiol, as you know, are one of the, not only, of course, because odor, you have a lot of molecules that can breed good or bad odors. But if we talk about not very friendly odors, mercaptans are one of the source of this type of not very welcome odor in our home. So and we, at least chemically speaking, we know that there is a reaction. After, is it working like formaldehyde when we are doing the reaction between the dry film containing trisamino and I would say gaseous or vapor of mercaptans? I don't know, because again, we cannot measure that today with a standard protocol.
Okay, thank you, Roman. A few questions on slide 9. If you could go back to slide 9.
Yep. This one?
A couple questions. Yeah, trisamino and AEPD have high VOC formaldehyde scavenging levels. Do you know how much % of formaldehyde can be scavenged by these products independently, or do they need to be used simultaneously?
You mean, I'm not sure to answer the question, to catch the question. Is it better to combine TRIS and AEPD? Is it the question?
Yeah, I think the big question is, do they need to be used together, or can they be used independently?
No, all the data I share today, they are used independently. Huh? It is AEPD or trisamino, not together. What I want to highlight with this spider graph is, if we look at all the multifunctional dimension of our product, so if we look at the in-can stability, if we look at the ability for the product to, to disperse pigment, it is a well-known effect of AMP, for instance, with TiO2 as an example. If we look at this, I mentioned that quickly, but the fact that our amino alcohol, they can boost BIT or CMIT, MIT, for instance, for in-can microbial protection. So this one, I think it's well understood. It is this reaction with formaldehyde. GHS classification is just looking at the safety data sheet, how the product is labeled, how the product is classified. And VOC, it is about, this slide can be different because there is about at least 7 definition of worldwide of how to define a VOC. So this one is with my European eyes, I would say. So neither TRIS or APD are considered as a VOC here, according to at least the boiling point definition. But again, they can be used separately. The difference is TRIS is going to primarily act as a scavenger. This is really the main function of the product. At the opposite, AEPD can develop much more functions in the coating. You can have the titanium dioxide dispersion, as you saw before. You see a difference between the hiding power with AEPD or with caustic. You have remember the gap. In terms of biostability as well, where here we can admit that if we have very good data with AEPD, we don't have yet data with trisamino. So it's a bit I should it's difficult to, because we do not have the data. So I do prefer to say that the product is not acting as a booster, because I do not have data to support this feature. But maybe a trisamino can also boost biostability. But with the existing data, TRIS is our best scavenger. APD can act a little bit as a scavenger, but offer again a broader multifunctionality.
On the same slide, it shows dispersion performance is poor for trisamino. Does this have an impact on the paint, meaning the paints using TRIS have poor dispersion performance?
No, you see, we do not see a difference of gloss. We do not see a difference of hiding power. So no, it's not negative. It's not positively affecting the dispersion, but it is not negatively affecting the dispersion. And this one, it's not because we do not have the data. We have the data. I know that we develop plenty of data showing that trisamino is not strongly adsorbed at the surface of pigments. So that's why trisamino is not acting as a weighting agent at the opposite to AMP, DMAMP, or AEPT. So it's a bit strange because if you look at the chemical structure, it seems to be in the same family of products, but sometimes a slight modification can drastically change the chemical properties, right?
Excellent. And I'll ask 3 more. I know we're at time here. What
sure.
about the solubility of trisamino crystals? Is there any special handling or preparation needed to incorporate tris into these? And what is the size? I mean, is there a size of the crystal that remains in the final paint?
Wow, good question. So yes, because trisamino crystal, there is one difference between AEPD and trisamino crystal. Is it the delivered form of the product? So AEPD is offered as an aqueous solution, so it is a liquid. Trisamino is crystal because we are offering the product as a powder. It's a pure product, 100% pure as a crystal. And what we can notice is, yes, we have to be careful because trisamino crystal, depending of the hardness of the water, if we are talking about water with a high hardness, we can see sometimes some, let's say, difficulty of solubilization of trisamino crystal, so leading to a little turbidity of the water. So yes, I think it's important to check and to look at the hardness, but it is not how to say that it's not only the hardness, but it is also what are the cation leaning to the hardness. If it's magnesium or if it's calcium or etc., we can have a different solubility aspect. Actually, trisamino do like to form, let's say, some complex with ions. So it is why sometimes we can have turbidity. It is possible to overcome this issue. So if I think one of the first check is to look at the solubility of tris as the powder in your water, if it's the water of your plant, and depending on the results, then we can have further discussion. What is interesting, and that's why I set up this way. What is interesting is we can add trisamino, so the powder, during the dispersion or during the letdown. I tested both. We prepare the same formulation, loaded trisamino early in the process, so as a dispersing agent basically, or at the end during the letdown, and the scavenging performance with our formulation was exactly the same. So there is no impact of loading the product at the beginning or at the end. So if it's more convenient to load the powder at the beginning, that's fine. If it's more convenient to load the product at the end because of the process, there is maybe multiple slurries going to different product. It is also possible to load the product at the end.
Thank you, Roman. Next question, and we'll do 2 more. I would like to know if trisamino can scavenge formaldehyde that is contained within a coating product itself in the can, or does it scavenge only formaldehyde that is contained within the air of a room?
You mean if you have some remaining formaldehyde in your product?
Yes.
Correct. Oh, no, it's also. I did not mention that. That's true before, but no. There is a clear reaction between, I would say, formaldehyde or formol, I would say, in water and trisamino. Yes, it is working, and it is in fact when where is it? Sorry, moving to this one. When we are preparing this product in our plant, this is exactly what we are doing. We are just putting together in a vessel trisamino trisamino and formaldehyde in water. So yes, it is working.
Okay, great. I'm looking through our list. We'll do 1 more question. let's see. Does the temperature of the room, hot or cold, impact the scavenging efficiency of the dry film containing trisamino?
It's also a good question. I cannot answer to this one because today we only performed scavenging efficiency with the standard, the regular testing condition, where the temperature is set up as 23 degrees C and humidity at 50%. So I don't know. Probably yes, because we know that the reversibility of this reaction is function of the temperature, right? As I mentioned. So I do not want to speculate too much, but if we just based our discussion on, let's say, the theoretical discussion, it should be slightly less reversible at low temperature and a little bit more reversible at high temperature. But it depends also. Yeah, I think it would be good to have a more detailed discussion around why the question and what is temperature range we are talking about. 23 is already, yeah, it's relatively high already. Huh?
All right, great. And we'll close with one final question. If I use trisamino, do I need to use an additional neutralizer such as AMP for adjusting pH in my formulation?
Unfortunately, yes, because the pK of trisamino is pretty low. The pK of trisamino is about 8.2. Which is quite low. So if you want to, usually when you want to set up your pH and also have the buffering effect of an amino alcohol, you are always trying to select the pK of your amino alcohol as close as possible to your targeted pH, right? So it means that for trisamino, it means that you are going to be limited to a pH between 8 to 8.2, which is clearly too low for a classic PAN formulation. So if you want to target the regular pH of about, let's say 8.5 to 9, which is today the most appropriate system, because if you are going higher than 9, sorry, you are going to likely destroy chemically your biocide. Most of the remaining biocide, they are very sensitive to pH higher than 9, so it's important to keep the pH lower than 9, but it's also important to keep the pH higher than 8.5 for keeping at least the stability and the rheologic property. And so if we look at this window, in this case, AEPD is probably most appropriate because the pK of AEPD is at about 8.8, so exactly in this operating window. And AMP, because you mentioned AMP in your question, Scott, AMP now is, I would say, is a little bit too high, because remember that the pK of AMP is a 9.7. So AMP is very good if you want to set up a pH like maybe a couple of decades ago, or maybe 1 decade ago, at about 9.5. But now, because the pH, the regular targeted pH is more, again, in between 8.5 to 9, it is more appropriate to think about AEPD. So a summary, trisamino pK of 8.2, AEPD a pK of 8.8, and AMP a pK of 9.7.
Okay, great. And with that, we'll wrap up Q&A and provide feedback to the participants on any questions that we did not get to during today's webinar.
Sure. And so maybe, Scott, we can say that this session, so the video is going to be available in the coming days. So if you want to share the content of this video, feel free to share the link. Also, we are, if you want to have a copy of the presentation, feel free to come back to me. I think you have my contact details in the invitation, so feel free to do so. And of course, if you have more questions, or if you want to try, so if you want to ask a sample, you can for the sample, you can directly go and ask a sample on our web page. And of course, if you have any further question, feel free to come back to me.
Great.
Thank you.
Thanks, Roman. Thank you for everyone for attending our webinar today. Thank you very much.